Hello and welcome to another session in physics. In this session, we'll be looking at the topic advantages and disadvantages of using constant volume gas thermometer as a thermometric substance. But before that, let us review the previous lesson. Welcome back. In our previous class, we've been talking about thermometric substances, and we said that thermometric substances are those substances that vary when there is a very huge increase or decrease in temperature. They vary in relation to temperature change. They are very sensitive to temperature change. We've talked about liquid in things like mercury and alcohol, being used as thermometric substances. We've talked about the advantages and the disadvantages. We've talked about why water cannot be used as a substance due to the fact that water wets glass and mercury does not wet glass. Though alcohol wets glass, alcohol has a very low freezing point. So because of that, it is a better thermometric substance than water as well. So in liquid and glass thermometers, the two basic thermometric substances are mercury and alcohol, respectively. At this point, let's talk about the constant volume gas thermometer as used in a thermometer as a thermometric substance. So what are the advantages of using a constant volume gas thermometer? The first one is that it gives more accurate measurements of temperature than any other thermometer. It gives more accurate measurement of temperature than any other kind of thermometer. So it's very important to put that into consideration. That is the advantage of constant volume gas thermometer. And now let's talk about the second advantage of constant volume gas thermometer. The second advantage is that it is very sensitive. It is very sensitive, and because of its high sensitivity, it can measure wide range of temperatures, Alright, so these are the two advantages of the constant volume gas thermometer. So now you know that the constant volume gas thermometer is the best kind of thermometer. But what are its disadvantages? Of course, it has some disadvantages. The first disadvantage is that due to its important nature, it is very expensive. It is very expensive, and because of that, it requires special handling and it requires care. Very expensive, requires special care. Most times, it will require the services of experts who know how to maintain and use it properly. That is the first disadvantage it has. Alright, the second disadvantage it has is that it is very cumbersome. It is very cumbersome. Cumbersome in terms of the fact that it is not so convenient to use. It is complicated somehow when it comes to making use of it. So it requires expertise to a reasonable extent to be able to make use of this constant volume gas thermometer. At this point, let us emphasize more on reasons why water is not used as a thermometric substance. One of the reasons why water is not used as a substance is because, one, water wets glass, like I mentioned earlier. It wets. Apart from the fact that it wets glass, it is colorless, it is transparent, it is colorless, and it does not expand uniformly. It does not expand uniformly. So we can say it expands randomly. Not expand uniformly. That caused what we call the anomalous expansion of water, where water keeps contracting. After a point, it starts to expand, and after expanding, it starts to contract again. Alright? So that is the third reason why water cannot be used as a thermometric substance. It can't exhaust it. And now, another reason why water cannot be used is because it has a small expansion, small range of expansion, small range of expansion. And what do we mean by this small range of expansion? It simply means that it can only expand between 0 degrees Celsius to 100 degrees Celsius. So because of this, it makes water not really good as a thermometric substance. So at this point, let's talk about clinical thermometers. Clinical thermometers are thermometers that are used, as the name implies, they are in hospitals. They are used for the measurement of the temperature of the human body. They are specifically designed for measuring the temperature of the human body. They have temperatures that range between 35 degrees Celsius to 45 degrees Celsius. The reason for that is because the normal human body temperature is around 37 degrees Celsius. So if your temperature were to drop below 30 degrees Celsius, then that would either mean that your body is getting too cold, which could result in low BP, low blood pressure, and this could constitute a health hazard that might act death for that person. On the other hand, if your temperature were to increase above 37 degrees Celsius, it will result in fever. If it gets as high as 42 degrees Celsius, you will suffer from high fever, at which point you will begin to have internal bleeding, nose bleeding, you will have seizures, and other chronic health. So there is no reason why a normal human body temperature will go above 43 degrees Celsius. So for that reason, a clinical thermometer is range of 35 degrees Celsius and 45 degrees Celsius. It is made specifically for the measurement of the temperature of the human body. When we sterilize a clinical thermometer in boiling water of about 100 degrees Celsius, it could result in the cracking or breaking of the thermometer due to the excessive temperature of the liquid. On the other hand, when you sterilize thermometer in boiling water of about 100 degrees Celsius, it could lead to the malfunctioning of the due to overexpansion of the capillary tube, as you can see from the diagram here, and also overexpansion of the mercury that is inside the bulb. At this point, let us talk about the fixed point of a thermometer. The fixed point of a thermometer. The fixed point of a thermometer simply refers to the fixed temperature. The temperature are two reference temperature points in a thermometer. We have the upper fixed point and we have the lower fixed point. They are used when we want to prepare a temperature scale. So for a temperature scale of Kelvin, we would have 373 Kelvin as the higher fixed point or upper fixed point, and 273 Kelvin as the lower fixed point. And for the Celsius scale, the 100 degrees Celsius, that is the upper fixed point, and the lower fixed point is 0 degrees Celsius. And then for the scale, the higher or the upper fixed point is 212 degrees Fahrenheit, that is the upper fixed scale, and then the lower fixed scale is 32 degrees Fahrenheit. When we talk about upper fixed point and lower fixed point, upper fixed point refers to boiling, simple, and then the lower fixed point refers to freezing point. That's it for the fixed perspective. Evaporation is a very important when it comes to the study of temperature. It is a process where liquid turns into vapor below its boiling point. It might interest you to know that evaporation can take place at all temperatures and not necessarily when something starts boiling. One thing that assists in evaporation is wind. wind assists in evaporation. Boiling, on the other hand, is something we're all familiar with, but it will be good to put it in terms that we can actually understand. So boiling is the change from liquid to vapor, the boiling point of that particular liquid. On the other hand, while wind has an effect on evaporation, wind has no effect on boiling. And that's it for today's class. Thank you for joining us in this lesson. To refresh your memory of what we've just discussed, please take the test that will appear on your screen.